Hey, what's up? We're here. We're live. And let's take this out. Let us take this out. Okay. Okay. Don't need this. Don't need this. Need this. Okay. Now last time, while wrapping up a question, we encountered structural formulas, right? And the structural formula, what it does is it gives you how they're arranged, and how you should see them is something like this. If you have, now it won't always be true, but with a little bit of practice and looking at questions, you'll be a lot more familiar. And if you're not asked to draw it, they definitely do talk about this in the exam. So this is butane. And if they ask you to write the structural formula, this is a display formula because you can see everything is displayed. If they ask you to draw the structure or write down the structural formula for this, you have to first appreciate what's bonded to each carbon, and then you condense it. So on the first carbon, this is what you have. On the second carbon, this is what you have. On the third carbon, it's just the two hydrogens. On the fourth carbon, it's very similar to the first carbon. And that's what you do. You write that down. So this is going to be just CH3. This is going to be CH2, CH2, CH3. And you write it, of course, without the gaps in the middle. So let's take away the gaps. Okay. I guess this is here now. Does that make sense? Easy peasy? We've done this? We know this? Hey Radha, what's up? Is this straightforward? Easy peasy? Alright. Now it gets a little confusing if you have an alkene. Here's an alkene. It's too long. And what would happen is the first part is still the same, right? What you do over here is look what you're doing. Either you can do this. Sometimes, depending on the question, you can write a double bond here, and that's fine. And they'll more often than not, they'll do it. They'll specifically ask what they're asking for. Sometimes they'll give you one line and tell you to write down the structural formula, and you just write down whatever they're asking, right? If they're asking you to draw it, you have to draw it, the display formula. Hi, Lionel. And another way of you'll see an alkene is, I'll rewrite it. You could also see it like this, and you should be able to tell this is an alkene. You can also see it like this, and you probably will never see it like this. Maybe a few MCQs here or there, right? How can I know the green, the one in green over here, is an alkene? How do I know if I look at this for the first time? How would I know this is an alkene? Yeah, the CH is a good hint, and the hydrogens are incomplete, right? And with practice, you can look at it and go, oh, that's an alkene. You don't know exactly where the double bond is, right? And there's no double bond here. And with a little bit of practice, it can go a long way, right? So just be aware of it, and I think it shouldn't be any issue at all. Let's try one more. And you can also have like a different kind of butene, can't we? You can also have this. Can you guys try writing the structural formula for this? Easy peasy, lemon squeezy, Japanesey. I don't know. How does it go? Hey Lionel, what's up? How's it going? It's only Lionel who's watching. And my phone's ringing. CH3CH? Isn't that a bit incomplete, my son? I mean, you have 4 carbons. Wait, okay. You press the enter too quick. I get it. Yeah, you can put the double bond or just remove the double bond in the middle. So you'll see this as CH3, CH, CH, CH3. Because if you take a closer look, this carbon has 3 hydrogens. La 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 la. Yeah, easy. And you could have a bit more complicated things showing up. Oh my god. You could have a few complications. You could have a more complicated molecule, like a let's say there's another CH3 over here, like that, right? So, and there's also 2 ways of writing this. Either you could write it this way, how it's exactly drawn, right? So you draw it this way. And this is more of the difficult examples I'm showing. So if you're kind of intimidated by it, good. And that's exactly. So if you use this logic, it will be CH3, CH2, CH, because it has, I'm not enjoying how it's coming out. I'll rewrite it, CH3, CH2. Now over here where the trouble is, it's carbon with a hydrogen and another CH3, and this is how you end up writing it. CH, CH3, and you're done with this carbon now, then you move on to the last carbon, which is just CH3. Can it be CH3, CH2, C2H4? No, C2H4 is just too confusing. C2H4 is also could imply that it's just this, possibly. Can't it? And it could just, you know what I mean, right? Another way of talking about this is the first 2 parts are fine. But if you focus on this carbon, again, that carbon, that damned carbon, that's where the trouble began, right? There's a CH3 on it and another CH3 on it, right? Or maybe you could write it like this if it's confusing. It's going to be a CH, I won't draw the hydrogens. It's a C, then a C, maybe H, यहाँ पे another CH3 and another CH3, right? So there are 2 CH3s. It's the same molecule, right? So you could also write this, they're all the same molecules on this page. You can also write this as CH3, CH2, CH, CH3 twice. Right? I'm not saying they'll force you to write it like this, but you should be aware if you see this or this, which is very unlikely, right? But it could happen, right? So these 2 mean the same thing. And if you think about it, it's not too far-fetched. Is this a little tricky? Or is this a little more or less straightforward? Work hard, welcome. 2 people watching, 4 likes. How this happen? Straightforward? Wow. Miral should be teaching us. Miral, teach us, senpai. Teach us. Miral, do you watch anime? Do you get the reference? Masum does. Oh. CH3, CH2, CH, CH3 twice. TK. Anime. Miral doesn't watch anime? Okay. Now, you see acids. Let's talk about acids. Now, alcohols or chlorofluorocarbons would be chlorine and fluorine on the hydrocarbon, right? They're more or less, just replace the hydrogen, right? Acids, even alcohols, right? I mentioned alcohols. With acids, it can get possibly a little weird. So we can talk about this. One thing you should know, and we talked about this, is that acid ka functional group will always be in the corner, right? Because how else is the carbon making 3 bonds? And it needs an OH, and the hydrogen at the end cannot make another bond. So it's always at the end. It's never in the center. Sensei. Hi. I don't know my Japanese. That suits much better. And this is how you write it. It's pretty straightforward. CH3, CH2, CH2, COOH, or sometimes CO2H as well. Either is fine, but between the two, you should go with this. Okay, straightforward. Hi, Mosen, how you do? How you doing? Does this make sense or no? Come on. Let's hear it. Straightforward or no? Okay. You guys get this? Okay, let's move on. Then we have, what could we possibly have after this? What could we possibly have after this? Let's actually, let's keep it. The more complicated it is, the more we'll learn. Yeah, my iPad is broken. H. Complete sense. Hi. Okay. We've moved on to the Eastern culture. Hey. Welcome. Mohsen. Abdullah Gheli. He just left. Yeah. So we're moved on to the Eastern traditions now. Instead of doing the salute, we'll do hi. The spelling is H-A-I. Is that understood? But there's no hi if there's no exclamation mark at the end. It doesn't make sense. It's hi. All right? Okay. How would we write this? You know about this. It's going to be CH3, CH2, same old boring alkane, then COO, CH2, CH3. What is the name of this ester which I have drawn? How are you liking our channel, Mohsen, so far? And are you doing AS? I think you're doing AS, right? What does that mean? Onigaishimasu. Oh, that doesn't mean anything weird. Ethyl butanate, are you correct? Absolutely. Ethyl butanate, that is the name. This is ethyl butanoate. Butanoate. Right? Okay, one thing I want you guys to realize, if you're ever confused with a molecule, try naming it. Naming it really organizes what that material is, and if it's different from maybe potentially another molecule that's drawn. And here's an example. And you think it might be a very similar molecule, but it's different. Ah, okay. Mawson is not replying. Oh, they all left. There's only one view. Viewer. Okay. Now, this is, I think, propyl propanoate, because it's just 3 each, so you don't even have to think about it. Propyl propanoate, propanoate, right? And the structural formula for this is going to be slightly different. CH3, CH2, CH2. Now over here, you want to highlight it's in a different way, right? So first you write the oxygen, then the carbon with the double bonded oxygen. And this comes out to look like OCO, CH2, CH3. And the difference between this is, if you see a COO, you write it as COO. If you see an OCOO, you write it as OCO. That could really easily turn into a song. OCO. Propyl propanoate. Hai. Seppuku. Say seppuku if you guys agree. I guess people don't know how to say hi. If you guys agree. Seppuku? Doesn't it have a U in it? Seppuku. 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 That's that's how you kill yourself. It's called like honor suicide something. That's seppuku. I'm sure the pronunciation is very different. It's just the English pronunciation. People don't get this. Only Masum said, hey, Miral, Hayam, Rahim. What say you? As soon as I... Okay, I guess it. Easy, straightforward. That's more or less it for structural formulas. Nothing else. I have nothing else. Okay, are we done? We done? We done. Okay. Now, I'm being a bit forgetful. Tell me if you guys have ever seen this diagram. And if you haven't, great. If you have, sorry for showing the same diagram. Tell me if you've ever seen this, especially in the last few days. I think we haven't. Have we seen this? Have not? Have not? Okay. This is... You can think of this as polyethylene or any polymer. think of plastic, right? You know, when we're talking about plastic bags, polymers in plastic bags and whatnot, think of, instead of drawing the carbons out, we're looking just at the chains of polymers. So what's going on over here is one has lines coming out, one's a branched polymer, and one is straight chained. So this could be polyethylene, whereas this could be a version of polyethylene not called polyethylene anymore, because, you know. So what they do is you take the same ethene and you kind of heat it, or make the process slightly difficult or different, not difficult, different, where it ends up branching a lot more. And we don't need to know how this happens, but you can do it with the same, even polyethylene, if you heat it slightly with higher pressure, polyethylene, it can turn into this. Now my question is, polyethylene is used in many different places. One is plastic sheets for shopping bags. So I'll try to draw a shopping bag, you know. One is harder plastics like mugs and whatnot, or plastic bottles, like tougher plastic. Can I ask which of the two is the tougher plastic in your opinion, and which is the softer plastic? What do you got? Because the mug is much harder plastic than the shopping bag plastic, right? So which of the two structures could be one, and which of the two structures could be not this? So we're trying to more or less, you know, we're looking at a lot of CH2s, if someone is still confused what we're looking at. And one is just branched, the other is not branched. What do you guys think? 50% of the time. The first would be the plastic gas. That would be my first impression as well, because it looks like it can easily bend and whatnot, right? But think about intermolecular forces. Which of the two will have stronger intermolecular forces? So the branches aren't long enough to kind of like knot it in place, you know? Nim, we missed you. It's been so long. Which would have higher intermolecular forces? The first one. So the first one would be harder to separate, or in other words, it'll be harder, you know, like stiffer. So the first one is the plastic that goes on to making more solid stuff. And the second one is your polythene bags. Shock. Big shock. More contact points. It has more contact points. Makes sense, right? Yeah. Okay. I would recommend. I would strongly recommend if you guys try drawing these two diagrams, just real quick, you know, like that, and one would be more branched, and just write two words on it, because you want to focus on the melting point and nothing else. It's weird, we were talking about, we were just having an anime talk and we were talking about senpais, and you're like quite literally going, notice me senpai. I forgot to, I uploaded the message very late on Noon Academy, so I guess that's why we have very few people today, just 2 people watching. Okay, can I move on? Let me know if I can move on. Plastics here to stay, the problem. And we'll talk about plastics. Oh, we didn't have our talk with plastics. Haras. Hello. Hello, hello, hello. Ace of Angels? What does that mean? Attack on Ace of Angels? What is that? Oh, okay. AOA, Ace of Angels. Okay. They're more expensive, and that's the issue. Do you guys feel weird if you're carrying your, have you guys seen that joke where like there's a dinosaur and there's like meteor flying and they die and their corpses everywhere, right? And millions of years later they're oil and they get extracted, transported in an oil container, go to a factory, turned into a plastic. And what does the plastic company do? Make tiny little plastic dinosaurs out of it. We've come full circle. We have come full circle when they make plastic dinosaurs out of plastic, like dead dinosaurs. Don't laugh, Haya. It's tragic. It's incredibly tragic. Right? That's incredibly tragic, yeah. It's just funny. Right? Okay. Okay. Can we talk about one of my more subjects that I hold a little slightly more dearly than others, which is food. We're gonna talk about some food. We're gonna talk about some Hanzala. Hello. Tragically amusing, poetically amusing. Okay, we have message. I just realized how hungry I am. Why did I order a salad for lunch? Okay. Food. And the idea is, tell me what this equation represents, and as soon as I write the first two, digits down, people are going to start screaming what it is. Guys, if you ever see me and if you get an A star, buy me food. Not that I'm a very bhuka person in general, I'm just so hungry right now, I want to just ask for food. Photosynthesis. What is this? What did I make over here? This is indeed photosynthesis. What's Sir Umar? What do you mean you're Sir Umar? Glucose? Or as us chemists would refer to this as sugar. What's another fancy name for sugar? Do you guys know? Do you guys know another fancy name for sugar? Do you guys know another fancy name for sugar? Another fancy name for sugar? What's that? Why is Haras laughing and screaming answers? Aren't they called saccharides? Is it just me, or are they called saccharides as well? Well, not polysaccharides. Saccharides. Saccharides is just a Greek word for Arasas chini. Comedian. Oh, we have Sweetings? What's a sweeting? I like how I'm the complete opposite of Sir Bilal, where he prefers the Q&A chat, and I'm like, I just spam my chat with you guys talking. What do you guys prefer, the Q&A thing or the chat? Last few days, the chat, not just here, even in my... Yeah, okay. Fair enough. Okay, let's move on. Have you guys ever seen a sugar, a glucose molecule? Have you guys seen it? It's pretty weird. Pretty weird. Pretty weird. Have you guys seen a molecule of sugar, of glucose? Have you guys ever seen a sugar molecule? A molecule of sugar? Some sugar? Huh? That sounds not so creepy. Yes or no? Oh, you think so? You think so? Okay, well, let's confirm if you have or have not. If you have or have not, this is a sugar molecule. Wow, big. There's a hair on my iPad. I'm trying to move it. That's a sugar molecule. Do we have to remember this? Yes. Am I lying? Yes. But the true question is, am I being annoying? Why am I lying? See, you don't have to know too much about it. This is what a sugar molecule looks like. And what do chemists do when you see a important, like very complicated sugar you don't care about? Haya will answer this. What do you see a very research? No, when you see a very complicated sugar molecule and you don't care about 95% of the molecule, what do you do to it? To talk about it, what do you do to it? We'll do electrolysis. Throw it away? Okay, no, I'm not getting serious answers. We put a rectangle on it and only highlight the important parts. I just simplified the molecule. Don't you see there it has many OHs on it? Do you not see? Right? So don't we, whenever we have a very complicated molecule, we just turn it into a rectangle and don't talk about whatever's in the complicated side. And if we want to focus on the OHs, we just take them out. Yeah, right? Come on. We'll start with electrolysis soon. But why it's there? Because you don't want to draw it every 2 seconds. And we don't care about, we just want to refer to one thing. Don't you simplify things? Isn't science all about simplification? You know, don't you ignore drag forces in physics? Right? Because of simplifications. Isn't science just nothing but simplifications and approximations? We can probably start electrolysis as soon as Monday, I feel. Or tomorrow. Okay. And this is what we do. And I'm gonna drop another bomb on you, guys. Now note, we don't care anything. Like, you can just watch this video once, and if you get it, you don't have to worry about it again. There's nothing I'm gonna show you that you have to remember. It's more like you're gonna see it in the exam. I want you guys to not be confused, right? And glucose is a part of it, and they just, you know, talk about stupid things, right? You guys agreed? You guys following? Yep. If you guys haven't seen the Avatar, why are you wasting your life studying chemistry? Go watch Avatar. Okay, the thing I want to talk about is we'll look at a particular kind of polymerization which we don't care what it is, how it happens, or anything, aside from the fact what I'm showing you. What's gonna happen is we just do not care, Because do you guys agree that both sides have alcohols over here right now? This will, with the help of, you know, things, will also polymerize. And we don't care. Aside from the fact that when a sugar or a glucose molecule polymerizes, it has just one O bond in the middle. Does this make sense? What could this sort of molecule be called? What do we call this molecule? Any ideas? Disaccharide? Yes.